So, hi and welcome. Can you hear me?
Yes.
Okay. Okay, just we're waiting 1 or 2 minutes for joining all of those other participants. Then we'll start our first session. Okay, so now we'll start our today's session. So, hi, and so I hope here all of you already get the previous recorded video class and also get all of those practice code and slide. Okay, so today is our second day. So, I simply share my screen. So now, can you see my screen? Can you see my screen now?
Yes, it is coming.
Okay. So let's. Okay. So basically today is our second day, and today I will try to discuss about this some topics such as how we can easily filtering and displaying the satellite images, mainly Landsat and Sentinel image, how we can easily filtering and displaying, as well as also download the different types of satellite images from Google Earth Engine. We also try to discuss about that band combination, how we can easily use the different types of band combination, such as true colors band combination, false color band combination, or others band combination, how we can easily use. And then how we can easily export the satellite imagery for the specific region, a specific time period, how we can easily download the satellite imagery. And then how to import, filter, reduce, clip, and display data in Google Earth Engine platform, any data set. How we can easily import, filter, reduce, and clip and display the data in Google Earth Engine. Then how to make the time series chart, any time series chart. Here I mentioned NDVI, but using this approach, you can easily create for any time series chart. It can be NDVI, NWI, EVI, SAVI, or LST, anything. And then how we can easily export any shape file. Suppose you want to export any boundary shape file, how you can easily export any boundary shape file using Google Earth Engine platform. I also try to discuss about that. Then calculating any indices from satellite images. So mainly how we can easily use the different types of raster calculation. Okay, different types of ratio calculation or raster calculation, how we can easily do using the Google Earth Engine platform. So let's go. First of all, this is the Earth Engine public data catalog. So in this, in Earth Engine public data catalog, we can easily access all of those satellite images: Landsat, Sentinel, MODIS, train, land cover dataset, atmospheric dataset. So lot of dataset we can easily access without downloading. Okay, when you want to work with ArcMap software or QGIS software, so first of all you need to download the satellite images. But in this time, when you use the Google Earth Engine platform, you don't need to download any types of satellite images. We can easily access all of those satellite images in Earth Engine public data catalog. And this Earth Engine public data catalog updating daily. Okay, so it's automatically updating. We can get the recent image automatically. It's updating daily. And in this Earth Engine public data catalog, we can easily access more than 200 public data set, more than 4,000 new images every single day. We can get the 5 million images, 5 petabytes of data. And this is the link about that. So you can simply go to this link, then it will be open the Earth Engine public data catalog. Okay, so this is the link about that Earth Engine public data catalog, where we find out all of those satellite images, all of those data set we can easily access. Or if you want, you can simply open the code editor. Simply open your code editor. And here you can see the search bar, search place and dataset. Click on here, you can see browse data catalog. Click on here. So now it also opened the Earth Engine public data catalog page. Okay. So in this time here we can get all of those dataset. Here you can see the surface temperature dataset, climate dataset, atmospheric dataset, weather dataset. Also you can see the different types of imagery, Landsat, Sentinel, MODIS, high resolution imagery, train dataset, land cover dataset. So a lot of data so we can easily access from here. As well as when you click on the Landsat imagery, so here I can get all of those Landsat image collection. Okay, Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. All of those things I can easily access from here. Also, you can see the Sentinel. So for the Sentinel, I can easily access all of the Sentinel image collection. For Sentinel 1, Sentinel 2, Sentinel 3, Sentinel 5, P. Okay, all of those dataset for Sentinel we can easily access from here. Also, you can see the MODIS. So in this time, we can get all of those MODIS product, MODIS data, so we can easily access from here. So in this time, I discussed about the Landsat. So mainly this Landsat collection. So mainly we can get the Landsat collection for the different time period. You can see the year of 2021 to present time. We can get the Landsat 9. Also you can see year of 2013 to present time, Landsat 8. 1990 to 2021, we can get the Landsat 7 ETM plus. Also you can see Landsat 5, 1984 to 2012, we can get the Landsat 5 ATM. Landsat 4, we can get this time period. Also you can see Landsat 1 to 5, we can get this time period. Okay. So in this time, all of those images has some specific characteristics or a specific band. Okay. In this time, suppose you can see the Landsat 9, Landsat 8, Landsat 7. So I simply click on the Landsat 8. So now I can get all of this information about the Landsat 8. So Landsat 8, we can this type of data. One kind of the data is the surface reflectance satellite imagery. We can also get the top of atmospheric satellite imagery. We can get also the raw image. Okay, so basically this is the raw image. From this raw image, it generated the surface reflectance as well as the top of atmospheric. Okay. So mainly the surface reflectance we are used for making the land use land cover classification map and other types of such as LST monitoring, this type of work. We can easily use the surface reflectance. And top of atmospheric we are used for the calculating the different types of indices such as NDVI, NWI are the types. But filtering process is the same. Okay, so when you want to filter the raw image or top of atmospheric or surface reflectance, this process is the same for any kind of images. Okay. So now I talk about that. What is the filtering process for any kind of satellite images? It can be Landsat, Sentinel, or surface reflectance, or top of atmospheric, or raw image. So any kind of image, how we can filter? Okay, so let's go. So I simply open my slide. So mainly for the filtering, it's depend on the three factor. Okay, when you want to filter the satellite images, it can be Landsat or Sentinel, both of image. These filtering factors are mainly three. One is that region of interest. Okay, suppose you want to need the satellite images for Landsat in Dhaka city. Okay, so first of all, you need to import your boundary shape file of Dhaka city. Okay, so which region you need the satellite images, you can simply import your boundary shape file. Okay, so it's just region of interest is the one factor. Another factor is that image metadata or image properties. Suppose I need only for those images which image will be not more than 1% cloud cover. So this is the another factor for image metadata or image properties filtering. And then third factor is that for filtering a specific time period. Suppose I need this image for year of 2017. I need this image for rainy season or wet season or summer season or any time period. Okay. So mainly when you want to filter your image collection of Landsat, we just filtering first of all according to our region of interest. Okay. So you need the satellite image for the Dhaka city or any specific region. First of all, you have to import your boundary shape file. Then you need to filter the image specific metadata or image properties, and then filter the specific time period, rainy season or year of 2017 or any time period you can filter. So now let's check the practical example. Suppose in this time I want to work for that surface reflect or top of anyone you can use. There is no problem. Both of is the same process when you want to filtering. So when I click on here, I can get this type of information. Here I can see, first of all, dataset availability date. We can get the data from year of 2013 to 2023. This time period you can see. Okay. So we can also get the dataset provider. So mainly this dataset provider is the USGS and Google. This is the provider about this dataset and Earth Engine snippet. Okay. So this is the Earth Engine snippet and this is that unique ID about this dataset. Okay. So every data set have a unique ID. Okay. So in this time, this is the unique ID for this data set. Landsat 8 collection, top of atmospheric reflectance. So this is the unique ID for this data set. Landsat 8 top of atmospheric collection. So this is the unique ID. We can get all of those images, all of those data set have a unique ID all time. As well as we can also get this type of description about this data set here you can see. So mainly this is the Landsat 8 collection. It is the top of atmospheric reflectance. And all of this information we can easily use, get from here. And also is the bands. So all of those bands we can get from here. You can see B1, B2, B3, coastal, aerosol, blue, green, red, near infrared, short of infrared 1, short of infrared 2, panchromatic band, band 8. Okay, all of those bands we can easily get from here. This is the band with their resolution, also their wavelength. Okay, so this is the band about that. As well as also you can see the image properties, all of those image properties. You can see the cloud cover land, collection categories. So all of those image properties we can easily access from here. So now this is my data set. This data set I need to import in my code editor. Okay, so how I can import the data set? It's very easy. Just simply copy this unique ID. simply copy this unique ID from here. Just simply copy and paste in your code editor. Okay. So now you can see this is the image collection, and this is the unique ID about that Landsat 8 top of atmospheric reflectance satellite images. Okay, full image collection for the whole world. Okay, so now this is my unique ID. I paste in here and then give a variable name. I store this image collection in a variable name. You can use any variable name. Okay, suppose I take a variable name. I put the variable name, suppose L8. Okay, so this is the variable L8. This variable stored the full image collection of Landsat 8 top of atmospheric reflectance for the whole world. Okay, so basically this is the L8. This is the variable. This variable stored all of the image collection for Landsat 8. So now I want to check how many images are available for the whole world between the time period year of 2013 to 2023. How many images are available? I want to check. I want to count. So for that, just simply use the print function and call this variable name L8 because this variable stored the full image collection. Simply copy the variable name and paste here. And then use a function for counting how many images are available. We use the function size function. So this size function counting how many images are available in this image collection. So now click to the run. So in this time it is starting to the computing how many images are available for the whole world between the time period year of 2013 to 2023. Okay, so in this time it calculated a big number for the whole world. Okay, so here you can see here I can get that more than 1 million images for this whole collection. Okay, so basically this is image collection for the whole world between the time period year of 2013 to 2023 for the whole world. Okay, so in this time this is my large number of image collection for the whole world. In this time I don't need for the whole world. I need for my specific region of interest. Suppose I need the satellite image for the Dhaka city. Okay, so for that I simply imported the boundary of Dhaka city boundary shapefile. So previous class I discussed about that how we can easily importing the boundary shapefile. So here I already imported the Dhaka city boundary. You can see this is my Dhaka city boundary. So just I simply import this boundary shapefile. Okay, so now simply click to the import this boundary. You can see it show as a table, default variable name as a table. I can simply change it. I put the name, suppose RY. You can put any name, no problem about that. So now here you can say I can get this image collection for the whole world. Okay, but in this time I don't need for the whole world. I need only for my region of interest in Dhaka city. Okay, so now let's check. So take a variable. I simply put the variable name, suppose filter region. Okay, filter region. In this time, this image collection for the whole world, and it is stored in this variable L8. I simply call the L8 and paste here. Okay, then use a function. This function called the filter bounds function. Okay, filter bounds function. So here you can see filter bounds function. So I simply copy that and then simply go to the docs tab and check about the description. So then we can get the you can see filter bounds function. So mainly filter bounds function, it filter a collection by intersecting with geometry. Okay, so in this time it filter a collection. In this time here I can get the large number of collection. This collection I need to filter by intersection with my region of interest. So in this time, what is my region of interest? My region of interest is the Dhaka city
boundary. And this Dhaka city boundary is stored in a variable. What is the variable name? ROI. I simply copy and paste. Okay. So now let's check how many images are available in the Dhaka city. Okay. In this time, what happened? This is my full image collection. Okay. So this full image collection intersection with my study area, Dhaka city. Okay. So now I want to check how many images are available for my Dhaka city region. So now let's check. So use the print function and then simply filter region. This call this variable name and use a size function. So now it determine how many images are available in the Dhaka city. What is the time period? Time period is the year of 2013 to 2023. Here we get the 419 images. Okay. So here we can get the 419 images are available for my region of interest in Dhaka city. Okay. So now in this time, I need to filter it also. Suppose from 419 images, I choose only for those images, which image will be not more than 1% cloud cover. Okay. So this is my another factor for image properties. In this time, from the 419 images, I need only for those images, which image will be not more than 1% cloud cover. So for that, just take another variable. Suppose filter metadata. You can use any variable name. I take the filter metadata variable. So now from 419 images, I need only for those images, which image will be not more than 1% cloud cover. So now this 419 images is stored in a variable. What's the variable name? Filter region. Okay. So filter region is stored at the 419 images. I simply copy that and paste here. And then use a function, this function called the filter metadata. Okay. So mainly filter metadata, filtering the image properties. In this time we can see, first of all, name, then operator, then value. In this time, what is the name? Name is mainly image properties name. So here you can see the image properties name. We get the cloud cover land. In this time, I want to use here the cloud cover. I need only for this image, which image will be not more than 1% cloud cover. So just put here the name. So cloud cover. And then operator, I simply put the operator is that less than and set the value. Set the value for 1. Okay. So in this time, what happened? In this time, from 419 images, it choose only for those images, which image will be not more than 1% cloud cover. Okay. So now let's check how many images are available less than 1% cloud cover for my region of interest. So just use here the print and call the filter metadata. Simply copy and paste and use a function, size function. Now it computing how many images are less than 1% cloud cover. So here we find out 63 images is available for my region of interest. This is the less than 1% cloud cover. What is the time period? Time period is the year of 2013 to 2023. Okay. So in this time, I don't need for the whole time period. I need the image only for the specific time period. Suppose summer season, rainy season, or year of 2017, a month of January. So any time period, I need these images. So in this time, I need to filtering the date. This 63 images for the whole time period, year of 2013 to 2023. But in this time, I need the image only for the year of 2021 or 2022 or any specific year or any specific season. Okay. So for that, what can I do? Just take the another variable. Suppose filter date. And this 63 images is stored in a variable. What is the variable name? Filter metadata. Simply copy and paste. And then use a function, filter date function. And now put here the start date and end date. Suppose I put the date 2020, 1st January from suppose 2020, December 31. So this is my 1 year. So now I check how many images is available for this 1 year. Just simply call the filter date and then use a size function and click the run. So now it shows how many images is available for the 1 year. We can get only for the 7 images are available. So in this time here, you can see this is the filtering process for the image collection. First of all, here I can get the very large number of image collection. for the whole world. But I don't need for the whole world. I need only for this image for my region of interest. So for that, I use here the filter bounds function. So this filter bounds function mainly intersection with full image collection. Okay, here I can get the only 419 images. After that, from 419 images, I choose only for this image which image will be not more than 1% cloud cover. So here I can get 63 images. Okay, from 63 images, I choose only for this image which image is available for year of 2020. Just I simply put this year of 2020. So here I can get the total 7 images. Okay, so this is the filtering process. So you can see we can get the large number of image collection, and finally we can get the small number of image collection for my study area. So first of all, this filter bounds mainly it give a answer for where you need this image. Then filter metadata mainly give the answer for that how, and then it provide the answer for that when. Okay? So mainly where, how, and when we apply and then filter the satellite images both times. So for the where mainly where you need this satellite images. In this time, I need the satellite image for the Dhaka city. For the where I use here the filter bounds function and put here the Dhaka city shapefile variable name ROI. Then how? In this time, I need only for this image, which image will be not more than 1% cloud cover. For the how, I use here the filter metadata and select the cloud cover less than 1. And then when I need this image? I need this image for year of 2020, 1st January to December. Okay, so finally I can get the result only for the 7 images are available for my study area. So now let's check all of this information for the 7 images. What is the acquisition time? What is all of those things we can easily check. So for that, I just simply use here the print function and then filter date. Only copy the variable name and paste here. So now it gives the information, all of this information about that. Here we can get, you can see. So click on here. You can get the total 7 element, means that 7 tiles or 7 images I can get in here. And every images have a total 17 bands. And here you can see all of those bands we can easily access from here. All of those images. And also get the feature. In the feature, we can get all of those image collection. Acquisition time. You can see the first image, 0 refers to the first image, is the year of 2020, 11th February, 26th January, 11th February, 30 March, 27 December, 9 November. So in this time, we can also get that acquisition time. As well as click on here. Here you can get all of this information about the image. You can see this is the type is the image, and this is the Lancet, this is the ID about this image. You can get all of those band for this image. Also click on here, can all of those properties. Suppose you can see cloud cover for this image is the 0.08, cloud cover land, all of this image properties information you can get from here. You can see data, acquisition, acquired time period about that. Okay, so all of those things we can easily access from here. A lot of information about this image. We can get about that. You can see image, path and row value we can also get from here. So all of this information we can easily access from here. So now in here, I want to work for the two-way. So in this time, I want to visualize the satellite images. After filtering, we have to visualize. So in this time, for the visualizing, we have used a different way. Suppose you want to show only for the single image or single time period image. Suppose in this time here, you can see this is a single image. Okay, so only for the single image. Suppose I want to show only for this image. Or also you can see the another image for that. Suppose you can see this is the another time period image. Lancet, you can see the 2022 30 March. So this is the another single image. So in this time, I want to show only for the single image without making any kind of composite. Okay, for the single image, how I can display the single image. For doing that, simply copy this ID. Okay, which time period image you want to need, simply copy this image ID. Copy this ID and then use a function ee.image and paste the ID in here. Okay, so this is the function ee.image and paste the ID in here. After that, just give a variable name. Suppose I put the variable name is that, suppose image. And then now this image is stored in this variable image. So now I want to display the result. Okay, so for that I simply use a function map.add_layer. In this time I want to display the image. So simply copy the image and click the just paste in here. Click on that. In this time, it added a layer. You can see it added a layer, but did not focus my study area. For the focusing the study area, we can simply use a function map.center object. Map.center object. Object is my study area, ROI. Put the zoom level, suppose 8. Then click to the run. So now it's focusing my study area and also visualize the satellite image, as you can see. Yeah. So as the tiles, you can see. So basically, this tiles acquisition time is that year of 2020, 30 March. Okay, and which cover my study area. Okay, so what is my study area? Okay, I also add the another layer for my study area. So just I take the use add the map dot add layer. In this time I want to add a layer for my shape file. My shape file is that ROI. Click to the run. In this time it also added the another layer for my study area of Dhaka city. So here you can see. Yeah, so this is my study area. So I also zoom. So you can see this is my study area. So this study area covered these tiles. So I can easily use it for this single image for my region of interest. And now here you can see this image look like that. Okay, look like that, this type of color. Okay, so it's the default color. We can easily use the different types of band combination. So for that, for adding the band combination, just click on here. And here you can see all of those band. We can easily add all of those band combination in here. In this time, suppose I want to add the band combination for RGB color or red, green, and blue channel. So just put here the red before, then green is the B3, and also blue for the B2. So red, green, and blue or natural color band combination. And custom, mainly the reflectance. I extract the reflectance range 98% for the better looking of the satellite images. So 98% I put the stress and then apply. So now we can get the better satellite images for my study area. Here you can see it's the tiles about the satellite images. Okay. So now in this time, I just need to clip with my boundary. Okay. In this time, other side not need. I need only for the my study area, Dhaka city boundary satellite images. Other not need. So just I simply use a function. This function. Okay. And before that, you need to import that. You can see import button. Import. So in this time, when I click on the import, you can see a new line of code added in my code editor. You can see it will be at image visualization parameter. Simply copy that and paste after the object name. So here you can see image. Okay. Then I have to put here the image visualization parameter because previous class discussed about that. It sequentially work. First of all, object, then visualization parameter variable, then put here the layer name. So suppose in this time it's showing the layer 1. I put this layer name is that suppose true color composite. You can put in no problem. So now click to the run in this time. And before that, this is the full tiles, but I need the result only for my study area. So just use a function, clip function. Use here the clip function. Clip with my geometry. What is my geometry? My geometry is the Dhaka city boundary shape file, which is stored in the ROI variable. Click to the run. So now I can get the result only for my study area of Dhaka city. Now I can see here I can get the image for the Dhaka city boundary. Okay, so now I can easily use this satellite image for the different types of remote sensing analysis, such as land use, land cover, NDVI map, LST, or any other types of remote sensing work we can easily do. As well as we can also download these satellite images from here for the specific band and use the satellite image for the other geospatial software. So in this time here you can see I show you only for the single image, so how we can easily use the single image for the single time period. As well as if you want, you can also use the different other technique for the make the different types of combination, such as median combination. Okay, in this time, this is the process for the single image. When you want to work for the single image, any single image, just simply click on here. Here you can get the feature, and then here which image you want to use, which image you want to need, simply click on here and then copy this id, and paste here. Okay, then we can get the single time period or single date image. Okay, in this time I will show you that how we can easily use all of those images. Here I can get total 7 images. So now this total 7 images I want to use and then create the median composite. Okay, so for the median composite, how we can easily do, it's very easy for creating the median composite. So for the median composite, suppose I want to create the median composite. For the median composite, we just use a median function. That take a variable name, suppose final image, and then call this filter date. Basically, this filter date is stored the total 7 images. In this time, I want to create the total 7 images and create the median image from the total 7 images. Okay, just use a function median. Okay, and this median clip with my shapefile. Shapefile is that ROI. So now you can see it also added the another image, but this image is the median image. Okay, it is the median image which come from the total 7 images. Total 7 images middle pixel value. Simply copy and paste and then click the run. In this time it create the another layer, and this image create from the median composite. Total 7 images, middle pixel value, create this combination. You can see I simply zoom in. So this is another process for the median composite. So mainly this median composite you need when you want to work for the big region. Suppose you want to work for the full Bangladesh country boundary. Okay, so for the full Bangladesh country boundary, one tiles or single time period image is not possible. Okay, for the single tiles is not possible to complete the full Bangladesh. Okay, so then we have to use the median composite and then easily cover the full Bangladesh. We can easily get the full Bangladesh satellite imagery at the same time. Okay, so I simply add in this time this is the median composite. This median composite I just need to add the visualization. So click on here. Suppose I want to add here the near infrared, red, and blue, and then 98% for stress the reflectance level, and apply. So now we can get the false color composite. Yeah. So you can get this type of color, you can see. Okay. In this time we can get this type of color, that combination, near infrared, red and green. Okay. And then I simply import that. Suppose I simply import, you can see import button. So when I click on the import, a new line of code will be added. You can see added. Simply copy that and paste after the object name. So this is my object. After the object, we always put here the visualization parameter and then put here the layer name. What is the layer name? I simply put this layer name such as a suppose false color composite. Okay. Then click the run. So now it will be added successfully. We can get the two color then combination images, false color and true color composite. But one image we can use here the single image. Okay, and another we just create the median composite. Okay, from the total 7 images we create the median composite and display this result. So now you can see we can get these images. So you can see true color composite. Also you can get the false color composite. Okay. So now this is the process about the filtering and visualizing the images. Suppose you want, sometime you need the single images, sometime you need the median composite. Anyone who is you need, you can simply use it and then further you can work. So in this time, using the same approach, you can easily do for the other images. You can see I show you the top of atmospheric. If you want, you can also use the same approach for the surface reflectance. You can see surface reflectance or raw image. Okay. For the surface reflectance, what you can do, just simply click on here. Here you can get all of those information. Just simply copy this snippet and filtering one by one, just filtering. Okay. And when you to display the result, if you want, you can show the single image or single date image. If you want, you can also show the median composite image. Okay. So now any question about the filtering, you can ask me about that for any function or in any question you can ask me. Any question in here for filtering and visualizing the image? Any question? Okay, for the visualization, mainly we are users of feature. Okay, so here you can see in this time, I also discuss a lot of things for the band combination for the classification class. So here you can see here, it's called the false color composite. Okay, so mainly false color composite when I use here, mainly it's the near infrared, red and green band, then I can get this type of things. Okay, this type of image visualize. So here you can see here in this time, the water body show as a black color. Okay, all time when you use this type of band combination, water body show as a black color. This is the water body, black color water body. So water body show as a black color and vegetation show as a red color. Okay, red color, this red color. So better red color identify for the better vegetation. Okay, so here you can see all time when you use this type of band combination, we can get this type of water body as a black color and vegetation show as a red color. This type of vegetation as a red color, and we can get suppose another band combination we can also use. Suppose it's called the short wave infrared one, near infrared and red. Suppose triplets 98%, and then apply it. So in this time we can get the another types of band combination. So or not. So it's the green. Well, let me check what is the problem. Okay, so in this time, suppose I want to add the another band combination. Okay, so true color, I simply add in here. So click on here and then put here, suppose short wave infrared one. It's the B6. So sorry, short wave infrared is the B6 for the Landsat. Okay, B6. Then near infrared is that B5. And then put here that near infrared green. Now let's check about the result, 98%, and apply. Okay, so now I can say I can get this type of image. So using this image, we can easily identify for the barren land as well as also wetland. So here you can see this type of brown color, identify about that barren land. You can see this type of color, identify about the barren land. Okay, also can see this type of identify about the wetland. We can easily get this. Also get the brown land, and we can also get this type of vegetation, green color about that. Okay, also can water body as a black color or dark color we can get in here. So mainly we are using here the different types of band combination. So we can easily get the different types of feature. Okay, suppose natural color, false colors, this type of combination we can use. For that, we can easily identify for the different types of feature. Okay, and it's very helpful when you want to make the land use land cover classification map. We are use the different types of band combination and collect the training point for the different feature. Okay, because different band combination we can easily identify the different feature, and it help you for getting the training point for the land use land cover classification map. Okay. Okay, so from here we can use any band combination. Okay, you can also search the different types of source. We can get a lot of band combination. Okay, natural colors, false color, or agriculture. We can get a lot of information about the band combination, and we can easily set the band combination from here. Any band we can easily use and get the different types of information from the satellite images. Okay, So this is the use for that, getting the band combination. Okay. So anyone any question?
Oh, sorry, I want to ask you.
Yeah, please.
Yeah, from the last session, as we were talking on when we will be doing
Yes, please.
on the part that when we will be doing the rent classification, and I saw that you were changing the band combination. Like you started with the with band 6, then band 5, and then band 3. So is that the rule that when we will be doing in the land classification we should follow that rule?
Yes. So mainly we are using the different types of band combination for identify the different types of feature. Okay. Suppose when I use at the natural color, then I can get this type of an image. When I use at that false color, I can get this type of image. So you can also follow this link. Suppose you can see this is the link about that. So it's also very suppose band combination for upland set 8. So here you can get the some information. Yeah, this is the link about that. And what is the band combination provided? What is the feature? So you can easily get from the lot of information. Okay, so you can see the link.
So as it comes, then we will be glad if you can also put in the slide over when we like the land set bands and band combination, so that we'll be able to be following up later on when we do our exercise.
So here you can see the Lancet 8 band combination. So you can also read about this full article. Then you can easily get a lot of information about the band combination. Such as you can see the natural color 432. When you put the 432 mainly green, red, green, and blue. Okay. So mainly when you put it the red, green, and blue, then what type of feature you can get. Okay. So mainly you can see it replicate the close to what our human eyes can see, and healthy vegetation is the green, Anandi flora is the brown, urban feature appears the white and gray, water is the dark blue or black. Okay. Also you can see it showing the color infrared, mainly near infrared, red and green. Okay. So mainly what type of feature you can get from here. Okay. Also you can see the short wave infrared 764. So this type of information you can easily get from here. And also you can say agriculture. When you want to identify agriculture feature, then we have to use the 652, this band combination. Then we can easily get identify about the agricultural land. Okay. And also get the barren land. Okay, this type of barren land you can easily get from here. Also you can see the geological feature. When you identify the geological feature, then we can use this type of band combination. Also you can see the bathymetric. When you want to identify the bathymetric feature, then we have to this type of band combination. Okay. So you can also read about that, and you can easily apply the different types of band combination from here. Okay, use here the different types of band combination and identify the different types of feature. Okay, and it also help you when you want to make the land use land proper classification map. So further I also discuss later about this topic. Okay, so in this time here I can get this Landsat image collection and also visualize the image collection. So in this time here you can see when I use the function filter bounds, I take a variable filter region. Also you can see filter metadata function, I take a new variable. Also filter date function, I also take the new variable filter date. Okay, so every function I take the new variable. Each time I take the new variable. But if you want, you can just take only for the one variable, and under this variable you can put all of this function. Okay, so let's go about that, how we can easily take only for the one variable. So for that I simply commenting all of those things. So first time I write the a lot of code for that your understanding, but when you want to work with that, just we can write only few code. Okay, so I simply just commenting all of those things from here. Suppose comment. So now it will be not work. So in this time I take only for the one variable. Okay, under this variable I put all of those function. Just take a variable, suppose image. Okay, or image 1. You can put any variable name. In this time this variable, I simply call my full image collection. Full image is that L8. So this L8 is the full image collection. Okay. Now, first of all, I need to filter it for my study area. So use at the filter bounds function. Filter bounds with my study area. With my study area ROI. After that, put here the dot notation. Okay. If in this time you can use anywhere, there is no problem. Suppose put here the dot notation, or if you want, you can also put here the dot notation. No problem. In this time, JavaScript programming is the no space is not matter in here. Suppose you can put here the dot notation, or if you want, you can also put here the dot notation. No problem. So in this time, I simply put the dot notation in here, and then put here suppose filter metadata. Filter metadata. And put here the filter metadata mainly cloud cover. Put here that less than suppose 1. Okay. After that, put here the another function. It's called the filter date function for a specific time period. So use here the filter date. Put here the start date and end date. So year of 2020, 1st January, from year of 2020 December 31. Okay. So in this time, you can see I just take only for the one variable, and under this variable I put all of this function one by one. So now it filter my image collection. Okay. So now if you want, you can check how many images you can get. Simply use the print function, print, and call the image 1. Simply copy and paste, and use the size function. So now here I can easily get all of those image information. Here you can say I can get the 7 images. Okay. So now I simply remove the size function. Then I can get all of those information about the 7 images. All of those acquisition time we can get from it. You can simply click on here. I can get the result. You can see I can get. So in this time, if you want to need the single image, just simply copy the ID. Just simply copy the ID and follow this approach. Okay, follow this approach for the single date image and display the image for the single date. In this time, I want to create the median composite. So for that, what can I do? Just I simply take here the median. So now it creates the median image and also clip with my boundary shape file. Use the clip with my boundaries that ROI. Okay. So now in this time, I just display the image. So use the map dot add layer function and call this variable name image1. Simply copy. And then I simply call I already imported the visualization parameter. So simply copy the variable name and paste here. I also put here the layer name. Suppose new image. Click to the run. So now you can see it also added another layer for that new image. We can get in here. You can see new image. It already add in here. Okay. So mainly we are follow this approach. Okay. Only write few code. Okay. But first time for your understanding, one by one, I understand what's code I can get the result. Okay. Suppose filter bounds we are used for that higher I need this image. Suppose I need the image for the Dhaka city. So I use the filter bounds and put here the Dhaka city boundary shape file. Then filter metadata mainly we are used for that. How I want to filter. I want to filter I need only for this image, which image will be not more than 1% cloud cover. Then this is the filter date. Filter date I want to need for that when I need this image. So I need this image for that year of 2020. Then I create the median composite and it also clip with my boundary shape file. Finally visualize the image and this is my visual parameter, band combination parameter of visualization parameter, and this is my layer name. So now you can see we can get the image in here as a new image. You can see it will be added in here. So this is the process for filtering and visualizing the satellite images. You can easily apply the same approach for any kind of Landsat 8 or Landsat 9, Landsat 7, Landsat 5, Landsat 4, 1 to 5. So all of those images collection you can easily apply and visualize the satellite images. Okay. So now I discuss about that how we can easily export these satellite images. Suppose I want to export these satellite images, and now I want to work for the further other software. Okay, so we can easily export this type of images and work with other software. So for exporting this image, we have to use a function for exporting any image, not only for that. when you want to export any image, it can be NDVI map, LULC map, satellite image, Landsat image, Sentinel image, any kind of image. When you want to export from here, just apply the same approach. So here you can see the export image. How we can easily export image for any kind of image, not only for this, any kind of image. So further, we have to use a function export image to drive. So this is the function we have to use. So in this time, this satellite image export and store it in my Google Drive. Okay. So now from here, I need to download it. Okay. It is stored mainly first time in Google Drive. So from here, I need to download it. So in this time here, you can see here, I can get all of this argument about my function, all of this argument. So now, first of all, I need to just create a curly bracket. So I want to make a dictionary. For the dictionary, you must use here the curly bracket. So use here the curly bracket.